2005 Grade 9 Friar Math Contest. Circles have the same center. The larger circle has radius of 10, smaller circle has radius of 6. Determine the area of the ring between these two circles. So basically what you would do is you would have pi r squared, which is the big radius, minus pi r squared, the small radius, like that. And then I guess we can factor out the big r is 10, the small r is 6. So that would basically be 100 minus 36, and that, I believe, is 64 pi. And that pretty much takes care of part A. Part B. In the diagram, the three concentric circles have radii of 4, 6, and 7. Which of the three regions, x, y, or z, has the largest area? Explain how you got your answer. X, let's look at that region first. That's just pi r squared. And the r that we're going to use in that case is 4. So that's 16 pi. Okay, so let's calculate them first, and then we can compare. Y will be calculated, let's see here, in a very similar way as we did in part A. So that would be pi r squared minus pi small r squared. In this case, those numbers would be 6 and 4 for those two radii. And that would give me 36 pi minus 16 pi, which is 20 pi. So that was 16 pi, and this is 20 pi. And then z, that would be calculated again in a very similar way to part A, and I guess the way we did for y. Subtraction of two circles. So pi r squared minus pi r squared. And this time the radii we're going to use are 7 and 6. So it's going to be pi 7 squared minus pi 6 squared. So 49 pi minus 36 pi, and that is 13 pi. So of these, the obvious answer in terms of which is the largest is y, because it's 20 pi, and the others are 16 and 13 pi. Part C, the three concentric circles are shown. The two largest circles have radii of 12 and 13. If the area of the ring between the two largest circles equals the area of the smallest circle, determine the radius of the smallest circle. Okay, so the area of the smallest circle, we'll just call it pi r squared, where r is the radius. And then the area of the ring between those two largest circles, that is calculated, we'll just call it ring. And that's calculated by subtracting the two circles. So pi r squared, where r is 13, minus pi r squared, where r is 12. And these two have to be equal. This has to be equal to that. So pi r squared is going to be equal to, what's 169 pi minus 144 pi. So the pi's all cancel, so you get r squared is equal to 169 minus 144 is 25. And therefore r would be the square root of 25, which is 5. And that's it. A game begins with a row of empty boxes. On a turn, a player can put his or her initial in a box or in two adjacent boxes. Anne and Bharati alternate turns. Whoever initials the last empty box wins the game. The game begins with a row of 3 boxes. Anne initials the middle box. Explain why this move guarantees him a win no matter what Bharati does. All right. Well, that's the first move, right? So let's say Bharati goes here. Then therefore that means that you have a B there, A here. Then the next move would be A, and A would win. Now let's say we have a slightly different scenario. A goes first. B this time puts the initial there. Well, then A can just put their initial right there. And then, as the question says, whoever initials the last empty box wins the game. So in both scenarios, Anne will win the game. An will win the game, however you pronounce that name. Part B, now the game begins with a row of 5 boxes. Suppose that the following moves have occurred. Show the move that On can make next in order to guarantee that he will win. Explain how this move prevents Bharati from winning. All right. So we want On to win, right? Okay. So we'll start with 5 empty boxes. 1, 2, 3, 4, 5. Okay. And we want On to win. Okay. So this is the first move. This is the second move, as they have shown. So the next move, we already have a B here and an A here, and we want On to win. So for On to win, we would put, let's say, the next move here for On. And then the next move, Bharati can put here. And then the next move, since there's only one left, On will put the initial there and then win. Another scenario is if you have the same kind of initial beginning where On puts his initial there, but Bharati then decides to put her initial there, but then On can just place there and then win. So as long as that is the next move, that is the A move that On can make next, no matter what Bharati does, whether she puts her initial here or initial there, On can move here or here and then win the game. So that's basically all they're saying, a move. And I think there's one other way of doing it, but they just want you to put a move, which means one move, and that pretty much explains the question. And then part C, again, the game begins with a row of 5 boxes. Suppose that the following move has occurred. Show the 2 possible moves that Bharati can make next to guarantee she wins. Explain how each of these moves prevents On from winning. All right, so we've got 5 boxes again. 1, 2, 3, 4, 5. Okay, so this is the first move, right? Okay, let me think about this. So, we have to show, what, 2 moves? Yeah, okay, so let's just start. This is the first move. Now, as you remember from the question, you can put two of those. Let me just remind you. A player can put his or her initials in 1 or 2 adjacent boxes, so that 2 is allowed. So that's what I'm going to do. And if that's the case, then now whatever On does, Bharati can win. So for example, if On puts there, Bharati can then put her initial here and win. If the scenario starts off the same, but then like that, and then we again use that same tactic of putting 2 there, and this time the next move is slightly different for On. He puts it there, no problem, because Bharati can then just put it there and win. So, and this is 1. They want you to put 2, so this is the first move, I guess. First example. Second example is very similar, but just, I think it's going to be shifted a little bit. So we start off here. Second move is going to be where Bharati starts off by putting those 2 boxes. So then On, let's say, puts it there, then Bharati can win by putting her initial there. And similarly, if we start off with the same, and Bharati puts her 2 initials there, and this time On puts initial there, then Bharati can just win by putting the initial there, and that's it. So that's pretty much all there is to this question. A Nakamoto triangle is a right-angled triangle with integer side lengths which are in the ratio 3, 4, 5. For example, a triangle with side lengths 9, 12, and 15 is a Nakamoto triangle. If one of the sides of a Nakamoto triangle has length 28, what are the lengths of the other 2 sides? So we have the ratio of 3, 4, and 5. So I'll just call it 3x, 4x, and 5x. Now they're saying that one length is 28. Now which one is it? Is it this one, or this one? Well, the number has to be divisible by 3 if it's this one. Is 28 divisible by 3? No. The number has to be divisible by 4 if it's that one, and 28 is divisible by 4. It would have to be divisible by 5, and 28 is not divisible by 5, so I'm confident it's not that one. Okay, so that means that 4x is equal to 28. That means x would be 7. So therefore 3x would be 3 times 7, which is 21. So 21 goes here, and then 5x is going to be 5 times 7, which is 35. So 35 goes there, and this is your triangle. Those are the integer side lengths. Part B. Find the length of the other sides of the Nakamoto triangle, which has a perimeter of 96. Okay. So, again, we're going to use the fact that the sides have lengths 3x, 4x, and 5x. Now, the perimeter would be the sum of those, and they're saying that's 96. So that pretty much that's the equation based on the information in the question. Okay, so let's solve for x. So this is what, 12x is 96. So therefore x is 8. So my side lengths are 3x, 4x, and 5x. 3x would be 3 times 8, which is 24. 4x would be 4 times 8, which is 32. And 5x would be 5 times 8, which is 40. So those are the integer side lengths of the triangle, which has a perimeter of 96. And part C. Determine the area of each of the Nakamoto triangles, which has a side length of 60. All right. So it's very similar. The side lengths are 3x, 4x, and 5x, right? So we're going to have 3 scenarios because we are not told which side length is 60. We're just told a side length is 60. So here I'll make the side length 60 corresponding to 3x. Here I'll make it corresponding to 4x, and here I'll make it 5x. And then each of these we'll have to figure out. If 3x is 60, that means that x is 20. So therefore 4x would be 80, and 5x would be 100. Right? And you can, I just did it quickly. You can do that a little bit longer. You can write it all out. Now the area would therefore be 1/2 base times height. These are right triangles, right? Yeah, they're right triangles. Okay. Yeah. So that means we can just use not Pythagorean theorem. The simple 1/2 base times height. Like for example, since they're right triangles, this is the base, this is the height. So in this case, the base is 60, the height is 80. So therefore that would be 2400. So there you go. That's one answer. Now we have to go through these guys. 4x is 60, so that means x is 15. So 3x would be 45, and 5x would be 75. So similar, this is one of those triangles where you have 45, 60, and 75 like that. Area would be 1/2 base times height. The base is 45. The height is 60. And the calculation would be 1350. And then finally this one, if 5x is 60, that means x is 12. So that means 4x would be 48, and 3x would be 36. Area therefore would be 1/2 base times height, which is 36 times 48, and that would be 864. So there you go. That takes care of part 3. Points B, C, D lie on AE as shown. The line segment AE has 4 basic subsegments and 10 subsegments. The supersum of AE is the sum of the lengths of all of its subsegments. If AB is 3, and so on, determine the lengths of the 10 subsegments and calculate the supersum. All right. So let's see here. AB is 3, BC is 6, CD is 9, and DE is 7. So these are all the 10 subsegments, right? So they want you to figure out, okay, so AB would be 3, AC would be 9, right? AD 18, AE 25, BC 6, BD 15, BE 22, CD 9, CE 16, and DE is 7. So the super sum is all of these guys, and when you add it all up, it's 130. All of these numbers here that I wrote in red. All right. Part B. Explain why it is impossible for the line segment AE to have the 10 subsegments of the lengths 1 through 10. Okay. Well, let's see. Not sure here. Well, what are the 10 subsegments? They are, let's just do them over here. I'm going to need a little bit more space here. So I have AB, AC, AD, AE, BC, BD, BE, CD, CE, and DE, right? Because you had this line from A to E. So we had A, B, C, D, E. I mean, it wasn't like this, but I'm just illustrating. Okay, and then they're saying that they want you to assign 1 through 10 for each of these lengths. And they want you to answer, why is this not possible? Okay. Well, there's a few ways of doing this, I think. I think I will do it in sort of a even and odd way. So let me explain. So if I don't look at the numbers and I just assign them a value, like for example, the length from here to here is A, this is B, this is C, and this is D. The lengths I'm talking about, like those lengths. That means AB would be A, BC would be B, CD would be C, and DE would be D. And then these guys, this would be A plus B, this would be A plus B plus C, and AE would be A plus B plus C plus D, and so on, right? So I'll fill them in. B plus C, B plus C plus D, and then C plus D. And then the supersum, which is the entire, when you add it all up, so that supersum is going to be 4A plus 6B plus 6C plus 4D. So that is the super sum. Now immediately I can factor out a 2, and that gives me, that shows me the fact that the supersum is even, because anything that is a multiple of 2 is even. Got it? So the supersum always has to be even, no matter what the numbers are. Okay, so that's actually fairly helpful, I think. Now, let's see what happens if these are the numbers assigned. This supersum, if you add up all these guys, this supersum is 55. And 55 is odd. So therefore, not possible, because the supersum always has to be even. So that's one way of showing that these numbers cannot possibly be the lengths of these subsegments. And now we've got, when the supersum of a new line, AJ, with 9 basic subsegments of lengths from left to right of 1 and so on is calculated, the answer is 45. Determine the supersum of the line segment AP with 15 basic subsegments of lengths from left to right of 1 through 1 over 15. Okay, so we've got this big long line this time, and it's going all the way from A all the way to P, right? And like I said, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Now, of course, it's not like this because I'm not drawing it to scale. I'm just kind of putting it out there to kind of illustrate. Now we have the painstaking task of listing all the sub-segments. Very painful, right? Very time-consuming. So, for example, I've got AB, AC, AD, AE, and so on, all the way up to AP. So I will write them out, and then I'll talk about them. So that's all the A's, right? And then similarly, you'll have all the B's. So you'll have BC, and then BD, and so on. And you guys get the point. And then next, you'll have all the segments that begin with C. So you'd have CD, CE, CF, and all the way down. So you just continue like this. And, you just list them all. And eventually, you're going to get all the way down to the final one, which is just OP. And I guess the second last one would be NO and NP. The third last one would be M, N, M, O, and MP, like that. And then there's a whole bunch in between. Got it? Okay, so that's all. There's going to be a lot of those subsegments. I didn't want to write them all out. Now we're going to talk about the lengths. Okay, so AB, they actually have given you that it's 1. And then, right, they've given you this is 1, this is a half, this is a third, and this is a fourth, this is a fifth, and so on, right? 1/7, 1/6, 1/7, 1/8, 1/9, 1/10, and obviously this is not drawn to scale, but that's okay. 1/13, 1/14, and the final segment of OP is 1 over 15. So now AC would be 1 plus a half, correct? AD would be 1 plus a half plus a third. AE would be 1 plus a half plus a third, if I can even write it in, plus a quarter. And you guys get the point. I don't have to write them all down. And then dot, dot, dot. And then similarly, the B's right here, these guys, the BC looks to me like it's a half. And then BD would be a half plus a third. BE would be a half plus a third plus a quarter. Right? And then so on down. Similarly, CD is a third. CE would be a third plus a quarter. And then you guys sort of get the idea. So, and then all the way down to the very end where OP is going to be 1 over 15. Okay, so now what we have to do is we have to add all these guys up. And the good news is that there'll be some sort of a pattern. So let's see if we can figure out that pattern. Now, before I do that, I want to write down how many of these segments are there. So for A, these A guys, if you count them, there's 15 segments. I believe. Yes, there should be. Yeah. And then so on down. There's 14 of these guys. And then there's 13 of these guys. And then all the way at the end, there's only one of those that begins with the letter O. Now, what I'm going to do is I'm going to designate each of these. I'm going to call this 1. I'm going to call this 2. I'm going to call this 3. And then I'm going to call this guy 15. And then that will allow me to sort of keep track of everything. Okay, so now I'm going to add up just the column 1. So this guy right here. Now pay close attention to these sums here. And I want to ask you, the number 1, how many times does it appear? It's going to appear in every single one. AB, AC, AD, AE, AF. So it will appear 15 times. Now, the half. How many times will the half appear? It does not appear in AB, but it does appear in AC, AD, AE, and so on. So it will appear 14 times. Now, the third, how many times does it appear? It doesn't appear in AB, doesn't appear in AC, but it starts to appear in AD. And then it will appear in AE, AF, and so on. So it will appear 13 times. And as you can clearly see a pattern here, it'll go all the way down to 1 over 15, which only appears once. Okay, and that will be in AP, by the way. All right, so now we move our attention to column 2, this column right here. Now, there is no 1 because BC starts off with a half, so there's no 1. But we do start off with a half, and how many times does half appear? It's going to appear in every single one of those B's, and there's 14 of them. So it'll appear 14 times. Now the third, how many times does it appear? It doesn't appear in BC, but it does appear in BD and BE and onward. So it will appear 13 times. And then ... So hopefully that makes sense. All the way down to this 1 over 15, which would appear in the very last one, BP. Okay, now let's concentrate on column 3. There are no 1s, there are no halves. We actually start off with a third. It appears for the first time in CD. It appears again in CE, and it would appear in every single one down to CP. So 13 times. And then similarly, hopefully you guys get the hang of this, all the way down to 1 over 15, which would appear only once for CP. And then eventually, you'd get down to this column, so ... down to column 15, which basically is just I'll have to move this up a little bit. Basically this column 15 has just this plus 1 over 15. So go over this a little bit. It's not so difficult. It's just hopefully you understand it. Try to do it in a systematic way to explain it to you guys. And then now you just add. So this guy looks like to me that 15 over times 1. These guys look like 28. Well, let's just write it as 2 times 14 times a half, which is essentially what it is. And then these guys look like 3 times 13 times a third. And even though I didn't do it, I can guess the next one will be 4 times 12 times a quarter. See, there's a pattern there. And again, even though I didn't write it out, I can guess the next one would be 5 times 11 times 1 over 5. And the next one after that would be 6 times 10 times 1 over 6. And so on. All the way down to I think the last one would be 15 times 1 times 1 over 15. And I encourage you to fill in the blanks that I didn't fill in. And then each of these, well, 15 times 1 is 15. This looks like to me 14. This looks like 13. This looks like 12. That's 11. That is 10. And then ... all the way to this, which is 1. Yeah. And then, okay, that's the sum from 1 to 15, and you guys can easily add that up. It'll be 120. And that is indeed the answer to this question. That is the super sum.